Good morning, students. Today I'll discuss with you respiratory systems. So, look, respiratory system. First, I will discuss with you oxygen depth. So, first of all, we'll discuss with you oxygen depth. I mean, when you have a short, intense burst of exercise such as sprinting, you generate energy for this anaerobically. Anaerobically or without oxygen. Okay, understood. So when we have a short, intense burst of exercise such as sprinting, you generate energy for this anaerobically or without oxygen. So when you stop exercising, you are still breathing heavily. When we are doing or when we are do what any exercise, that time after exercise still breathing heavily, and this is your body taking in extra oxygen to repay the defect. Okay, so well, that is the simple solution, but there is a little more to it if you want to look a bit deeper. I mean, look, students, when we have any short intense burst of exercise, I mean, when we are doing any exercise or when we do exercise or when we will do any exercise, that time we need oxygen. But when we will do without oxygen any exercise, that time stop exercising and you are still breathing heavily. That time, I mean, this is your body taking in extra oxygen to repay the debt. Understood? And well, that is the simple solution, but there is a little more to it if you know or if you want to look a bit deeper. So, true, your body has work anaerobically and without oxygens or without oxygen, and will have produced energy without some of the oxygen it would normally have used performing a low intensity exercise such as slow steady running. And the difference between the oxygen and body required and what it actually managed to take in during the sudden sprint is called oxygen defect. So look, student, actually this one with a diagram we discuss oxygen date with a diagram. So this one, actually this is a look. Look what first time oxygen date this diagram. With this diagram, I mean what? Look, oxygen date means this one. What? This one oxygen date. This one oxygen date. And oxygen date also are here. Okay. And look, this is a time taking. Okay. And oxygen comparisons. Oxygen comparisons. Okay, so understood what? When you stop sprinting or any running and start to recover, you will actually need more oxygen to recover than your body would have liked to use had enough been available. So this is called excess post exercise oxygen consumptions. Understood? Now we will discuss with you why does it take more oxygen to recover. What? Oxygen date already discussed with you, all you are understood. So now I will discuss with you why does it take more. Why does it take more what? Why does it take more oxygen to recover? Oxygen to recover. So answer, what is the answer? Answer, actually you needed to replace the oxygen the body needed but could not get oxygen defect. So breathing rate and heart rate are elevated to remove carbon dioxide, and this needs more oxygen. So body composition or body temperature and the metabolic rate are increased, and these need increase, and these need more oxygen. So after exercise there are other factor causing in an increase in oxygen needs as well as repaying the back of oxygen during exercise. Understood? And look the chart, I mean above the chart I have already drawn. So what the chart, what often seen that shows how to amount of oxygen used by the body change over time. I mean look what, like this. Okay, so oxygen date and oxygen date. So oxygen consumption. So this diagram, amount of oxygen used by the body changes over time in the breathing. I mean in the beginning the body works anaerobically, I mean without oxygen, leaving an oxygen defect. So over time the oxygen consumption level out to steady state. After exercise the oxygen is paid back. Understood? And I mean this called oxygen date, and notice the area of oxygen date is greater than the area of oxygen defect for the reason state above. Understood? And now I'll discuss with you what has lactic acid go to do with oxygen date. Look students, lactic acid, actually lactic acid is a, so look what I am saying, lactic acid. Lactic acid. So lactic acid, actually lactic acid is byproduct of exercising without using oxygen, I mean anaerobically, and it is essential this is removed, but it is not necessarily a waste product. Understood? And it is recycled into other useful chemicals. So during prolonged, I mean lactic acid during prolonged intensive exercise, I mean example 800-meter race, and the heart rate may get half its energy from lactic acid, and it is converted back to uric acid and used as energy by the heart and other muscles. Understood? And look, it is thought that 70% lactic acid produced is oxidized, and 20% is covered by glucose in the liver. So 10% is converted to protein. Okay, and another important thing, so what, how long does it take to remove lactic acid? How long take to remove? How long take to remove lactic acid? What? Lactic acid. Understood? How long take to remove lactic acid? So about 1 hour if cooling down is gentle exercise, and what, it can take 2 hours or more if you don't warm down with gentle exercise. Understood? And exercise for healthy lungs, and effect of exercise on respiratory systems. So for today's these are all, and thank you so much. And next day, I mean next class, I will discuss with you effects of exercise on respiratory systems. So what? effect of physical exercise and training on respiratory system. Understood? So thank you for today's. So carefully listen my voice and read at your home.